Okay, this is Mr. Peterson, and we're going to look at some examples for the Chapter 1 review in Algebra 2, and this is Part B of that chapter. So for the first two problems, problems 1 and 2, you're asked to determine whether a given point is part of the solution set. So I've got this point right here, x being 4 and the y being -3, and we're going to simply plug these into the two equations that were given here. Let me highlight things so you can see it better. So we're going to plug into this first equation, and maybe you can see that I put a 4 in for the x and a -3 in for the y. And if you do all the number crunching, that leads to 22 equaling 22, which is a true statement. When you plug the same values, the same x and y values, into the other equation, it yields a false statement at the bottom. 27 equals 29, and that leads you to the final conclusion that 4 -3 is not a solution. In order for it to be a solution, it has to work in both equations. And by the way, that's how you would show that it is a solution, is it would have to work in both of them. Okay, so in the next one, our goal is to solve by graphing. And so what we're going to do here is we're going to graph both lines. So you can see I start out with this top equation, which is highlighted in yellow here. And once you got the y by itself, and that's all this work here, you can see the slope is 4/3 and it hits at 7. So I come up here and I highlight the 7 on the y-axis, and I count up 4 and over 3 to get my slope. And then I back down that by going down 4 and back 3, down 4, back 3, and so on. So that's that first line. I've got the blue equation highlighted in yellow there. And then I've got the black equation is highlighted here in blue. Maybe you can see the blue area down there. And we copied that down and solved for y. And you can see that's a line that hits down here at -6 and goes 5 down and 6 to the right, 5 down and 6 to the right, or 5 up and 6 to the left. And that puts us right on that little dot. -6, -1 is being the only point that makes both equations true. So the solution is right here, the place of intersection, -6, 1. So basically you graph both lines and find where they cross. Now there's going to be some exceptions you may or may not run into. One of them is when you're really dealing with both lines being the same line. And you can see that after I work this one out here, all the work on the yellow side of it, the first equation, gives 3x minus 2. So I graph that one by finding -2 on the y-axis and going up 3 and over 1. And then I did the work on the second equation. It's highlighted in blue here, and it yields the same line as we just got. So what we have is really just one line twice in the same spot. When one line is on top of the other, we say that they're coinciding, and there's an infinite number of places where those two lines intersect, so there's infinitely many solutions, and this situation is called a dependent system. Okay, so the next example I have here for these problems is, just in case you get a pair of parallel lines, then you can see these have the same slope here, but they have different y-intercepts. One hits up at 4 and the other hits the y-axis down at -3. Parallel lines and no solution, and this is called an inconsistent system. So those are the responses you would do in the case that you get one just like this. Okay, and we'll pick up in the next video set with problem number 7, that section.